The fourth learning objective is to use discounted cash flow models to make capital investment decisions. Neither the payback period nor the ROR recognizes the time value of money. That is, these models fail to consider the timing of the net cash inflow an asset generates. Discounted cash flow models, the net present value, and the IRR overcome this weakness. These models incorporate compound interest by assuming that companies will reinvest future cash flows when they are received. Over 85% of large industrial firms in the United States use discounted cash flow methods to make capital investment decisions. Companies that provide services also use these models. The net present value and internal rate of return methods rely on present value calculations to compare the amount of the investment, that's the investment's initial cost, with its expected net cash inflows. Recall that an investment's net cash inflows includes all future cash flows related to the investment, such as future increased sales or cost savings netted against the investment's cash operating costs. Because the cash outflow for the investment occurs now, but the net cash inflows from the investment occur in the future, companies can only make valid apple-to-apple comparisons if they convert. The cash flows to the same point in time, namely the present value. Companies use the present value to make the comparison rather than the future value because the investment's initial cost is already stated as its present value. To decide how attractive each investment is, we find its net present value. The net present value is the net difference between the present value of the investment's net cash inflows and the investment's cost, cash outflows. We discount the net cash inflows using management's minimum desired rate of return. This rate is called the discount rate because it is the interest rate used for the present value calculations. It is also called the required rate of return because the investment must meet or exceed this rate to be acceptable. The discount rate depends on the riskiness of investments. The higher the risk, the higher the discount or interest rate. We then compare the present value of the net cash inflows to the investment's initial cost to decide which projects meet or exceed management's minimum desired rate of return. Greg's Tunes is considering producing CD players and digital video recorders, or DVRs. The products require different specialized machines that each cost $1 million. Each machine has a 5-year life and 0 residual value. The two products have different patterns of predicted net cash inflows. The CD player generates more net cash inflows, but the DVR project brings in cash sooner. To decide how attractive each investment is, we find its net present value, or NPV. The net present value is the net difference between the present value of the investment's net cash inflows and the investment's cost, or cash outflow. Greg's expects the CD player project to generate $305,450 of net cash inflows each year for 5 years. Because these cash inflows are equal in amount and occur every year, they are an annuity. Therefore, we use the present value of annuity of $1 table, that's Appendix B, Table B2, to find the appropriate annuity present value factor for I equals 14% and N equals 5. Next, we simply subtract the investment's initial cost of $1 million cash outflow from the present value of the net cash inflows of $1,048,610. The difference of $48,610 is the net present value. A positive net present value means that the project earns more than the required rate of return. A negative net present value means that the project earns less than the required rate of return. In Greg's Tunes case, the CD player project is an attractive investment. The $48,610 positive net present value means that the CD player project earns more than Greg's Tunes' 14% target rate of return. In contrast to the CD player project, the net cash inflow of the DVR projects are unequal. $500,000 in year 1, $350,000 in year 2, and so on. Because these amounts vary by year, Greg's Tunes managers cannot use the annuity table to compute the present value of the DVR project. They must compute the present value of each individual year's net cash inflow separately, as separate lump sums received in different years. Using the present value table of $1, Appendix B, Table B1, Exhibit 2112 shows that the $500,000 net cash inflow received in year 1 is discounted using a present value factor of I equals 14 and N equals 1, while the $350,000 net cash inflow received in year 2 is discounted using a present value factor of I equals 14 and N equals 2, and so forth. After separately discounting each of the 5 years' net cash inflows, we add each result to find that the total present value of the DVR project's net cash inflow is $1,078,910. Finally, we subtract the investment's cost of $1 million, which is the cash outflow, to arrive at the DVR project's net present value of $78,910. Exhibits 2111 and 2112 show that both the CD player and the DVR projects have positive net present values. Therefore, both are attractive investments. Because resources are limited, companies are not always able to invest in all capital assets that meet their investment criteria. As mentioned earlier, this is called capital rationing. Greg's may not have the funds to invest in both the DVR and CD player projects at this time. In this case, Greg's should choose the DVR project because it yields a higher net present value. The DVR project should earn an additional $78,910 beyond the 14% required rate of return, while the CD player project returns an additional $48,610. This example illustrates an important point. The CD player project promises more total net cash inflows, but the timing of the DVR cash flows loaded near the beginning of the project gives the DVR investment a higher net present value. The DVR project is more attractive because of the time value of money. Its dollars, which are received sooner, are worth more now than the more distant dollars of the CD player. If Greg's had to choose between the CD and the DVR project, the company would choose the DVR project because it yields a higher net present value, $78,910. However, comparing the net present value to the two projects is only valid because both projects require the same initial cost of $1 million. When projects have different investment amounts, compute the profitability index also called the present value index. The profitability index is computed as follows. Profitability index equals present value of net cash inflows divided by the investment. The profitability index computes the number of dollars returned for every dollar investment, with all calculations performed in net present value dollars. It allows us to compare alternative investments in net present value terms, like the net present value method, but it also considers differences in the investment's initial cost. The profitability index shows that Project C is the best of the three alternatives because it returns $1.21 in present value dollars for every dollar invested. Projects A and B return slightly less. When cash flows are equal in amount and occur every year, they are an annuity. Therefore, we use the present value of annuity table. If amounts vary by year, managers cannot use the annuity table to compute the present value of a project. They must compute the present value of each individual year's net cash inflows separately as separate lump sums received in different years, using the present value of $1 table. Many assets yield cash inflows at the end of their useful lives because they have residual value. Companies discount an investment's residual value to its present value when determining the total present value of the project's net cash inflows. The residual value is discounted as a single lump sum, not an annuity, because it will be received only once, when the asset is sold. In short, it's just another type of cash inflow of the project. Another discounted cash flow model for capital budgeting is the internal rate of return. The internal rate of return is the rate of return based on discounted cash flows a company can expect to earn by investing in a capital asset. It is the interest rate that makes the net present value of the investment equal to 0. Internal rate of return equals the present value of the investment's net cash flows minus investment's costs. The present value of the cash flows equals 0. In other words, the internal rate of return is the interest rate that makes the cost of the investment equal to the present value of the investment's net cash inflows. The higher the internal rate of return, the more desirable the project. If an investment will result in equal annual cash flows, the computation of the internal rate of return is as follows. Divide the cost of the investment by the annual net cash flow. The result is the present value of an annuity factor. Use the PVA table. Locate the row where the numbers of periods equals the life of the asset. Go across the row until you find that factor that is the closest to the amount in step 1. Look at the column heading to determine the interest rate. Let's first consider Greg's CD player project, which would cost $1 million and result in 5 equal yearly cash inflows of $305,450. We compute the internal rate of return of an investment with equal periodic cash flows, which is an annuity, by taking the following steps. Number 1, the internal rate of return is the interest rate that makes the cost of the investment equal to the present value of the investment's net cash inflows. So we set up the following equation. Investments cost equals present value of the investment's net cash inflow. Investment costs equals the amount of each equal net cash inflow times the annuity present value factor. I equals a question mark and N is given. Next, we plug in the information we do know. The investment cost is $1 million. The equal annual net cash inflow of $305,450, but assume there is no residual value and the number of periods is 5 years. $1 million equals $305,450 times the annuity present value factor. I equals a question mark, N equals 5. We then arrange the equation and solve for the annuity present value factor. $1 million divided by 305,450 equals the annuity present value factor. This is 3.274, rounded to 3 places. Finally, we find the interest rate that corresponds to this annuity present value factor. Turn to the present value of annuity of $1 table, that's in Appendix B, Table B2. Scan the row corresponding to the project's expected life, 5 years in our example. Choose the columns with the number closest to the annuity present value factor you calculated in Step 3. The 3.275. The 3.274 annuity factor is in the 16% column. Therefore, the internal rate of return of the CD player project is 16%. Greggs expects the project to earn an internal rate of return of 16% over its life. Using a 16% discount rate, the project's net present value is 0. In other words, 16% is the discount rate that makes the investment cost equal to the present value of the investment's net cash flow. To decide whether the project is acceptable, compare the internal rate of return with the minimum desired rate of return. To decide whether the project is acceptable, compare the internal rate of return with a minimum desired rate of return. If the internal rate of return exceeds the required rate of return, invest. If the internal rate of return is less than the required rate of return, do not invest. Many times the exact factor will not appear in the table. If this happens, say a 4.00 factor, find the closest two factors. 4.00 is found between 3.889 at 14% and 4.111 at 12%. Therefore, the internal rate of return must be somewhere between 12% and 14%. When comparing capital budgeting methods, the payback period and the rate of return ignore the time value of money. The discounted cash flow methods are superior because they consider both the time value of money and profitability. These methods compare an investment's initial cost, which is cash outflow, with its future net cash inflows, all converted to the same point in time, the present value. Profitability is built into the discounted cash flow methods because they consider all cash inflows and outflows over the project's life. Methods that incorporate the time value of money include net present value and internal rate of return. This short exercise provides information to use for the next problems. Question number 1, what is the project's net present value? And is this investment attractive and why? What is the project's... This is assuming the expansion has no residual value. Is it still attractive, and why? The project's internal rate of return.